So the lab was to create an update function and then update the velocity, create a velocity member variable, and make the ship move in the update function based on the velocity. So I'm going to create a virtual void update, which takes a float for a delta time. And I'm going to take this function, I'm going to implement it inside the CPP file. And all this function is going to do is it's going to update the position based on a velocity member variable. So just like how position is a vector 2f, I'm going to make a velocity here. And by default, I'm going to get my velocity. This is just for me. I didn't ask you guys to do this, but this is good practice. I'm going to set my velocity to 0 by default. You can do it like this in the constructor, or you can do it in the member initialization list by doing this, like so. Either way, I'm going to set the velocity to 0 because I don't want them to pass in a velocity. The player's always going to start without moving. Then in my position, I'm going to add in the velocity multiplied by delta time. So I'm going to take my velocity, multiply it by delta time to scale it based on the rate of updates that I get, and then inject that into the position variable here. As well, I asked you guys to take the position and inject that into sprite. So the sprite has a position as well. Just like what we did in the constructor, we need to take the position and update the sprite's position too. Okay. So the other thing I asked you to do is just set the velocity. What did I ask? 200, comma 100. So just set the velocity here in the update, just to see the ship be moving at all. Now the thing that is missing is that when I run this, the ship's not going to move. In fact, I don't even have a ship right now. Oh, because I did the crazy thing with 10,000 ships in here. Let me just uncomment this. And I'm going to convert this from a vector back to a single pointer, just because we don't need it to be an array. And then I have my player, and I'm already calling draw on the player, but I am missing the part where I call update on the player. It's going to draw the player now, however, it's not going to actually move the player even though I set the velocity. Let me make sure I have this as well. So even though I'm setting the velocity, it's not moving because this function for update is never getting called. And I can prove that by putting a breakpoint in here. So by injecting a breakpoint, if I were hitting this, you would see it turn with a yellow arrow like this. This yellow arrow indicates that, hey, I've hit the breakpoint and that's the next line of code that will run. However, I'm seeing no such behavior for update. That's because we haven't called it. So we got to go into engine. And in a good spot here, I'm going to do it right below before we call clear. I'm going to get my player. And I'm going to call update on it. And I need to pass in a delta time. So just for the sake of testing, I could just pass in a number here. However, that's not really great. I'm going to show you guys how to pass in a better delta time. That's probably way too big. And this number here, delta time, is something that we want to control. So see how he's moving kind of like choppily? Like kind of like not moving at a really consistent rate. We need to calculate the delta time using a clock. So here, we're going to make a clock. And then we're going to make a delta time variable by restarting the clock. So this is a variable called delta time that is a time type, and we're going to pass this into our update function here. All right. And now update is getting called, and now our ship is actually moving at a consistent rate. Let me also make it so that he's in the top left corner here. Maybe halfway through. Kind of not really halfway, but top left. So he's moving now every time because I set the velocity. And I can set this velocity so that he moves up. And this velocity controls his position change over time. So now I want to make it so that if I'm pressing up, it causes the player to move. I don't want to move him unless they're pressing up. So instead of setting the velocity here, like so, what I can do is I can add a behavior in here, is key pressed, up, this if statement right here, and I can just set the velocity like so. I don't set the x velocity at all. And I just put this right inside the player function. So player's here. I'm pressing up, and he's moving. Unfortunately, he still moves even though I'm not pressing the button. So what do I have to do? Well, I have to reset the velocity I can either do this in an else statement like so. So if he's not pressing up, I can set the velocity to 0. Or I don't actually need this else statement. I can just set it to 0 every frame. And if I happen to be pressing up, it'll override the 0 with a negative 100. So now, as I'm pressing up, it causes him to move up. I'm doing this right inside the update function. Kind of like how I was changing the color for the shapes before in the draw function, I can put functionality specific to the player right here. Okay. Next thing I asked you to do was to create a concept of an angle. It's very similar to the velocity, but angle is just going to be a float. And you can rotate things in SFML. I'm going to take this angle, I'm going to initialize it here in my member initialization list to 0. And then what I can do is I can call mSprite set rotation based on my angle. Now angle here, I can set, let's say I set it to be, I don't know, 45. And I can set this thing to be 180, like so. So I can change this in the update. However, I only really want to change it when I'm pressing a key. So if I press this left key or the right key, I want to adjust the angle by adding or removing to it based on delta time. So I want him to rotate at 360 degrees per second. So that's 360 times dt. And I'm going to add to it when I press, or I'm going to subtract from it when I press left. And I'm going to add to it when I press right. Notice I'm not even touching the main function. I'm literally doing this all in update. So now I'm subtracting or adding angle by pressing the keyboard keys. Like so. Yeah, it's a Tokyo Drift style spaceship drift. And the reason why this is not rotating around the origin is because we need to set the origin of this thing, and we need to set the origin based on the size of the ship, which we can get. By reading the texture. So by setting the origin, we can properly make it so he's rotating about his middle. We adjust the origin from being the top left corner to being the middle of the ship. Okay. And that was 1 through 8. So number 9, concept of acceleration. So acceleration is a change in velocity over time. And velocity is a change in position over time. So acceleration looks very similar to how we're handling velocity. Except instead of position we're updating, we're going to update the velocity. So we're going to add another vector for acceleration. And I'm going to initialize this vector for acceleration the same way. It starts at 0 in the constructor. And what I'm going to do is, before I update the position, I'm going to update the velocity. It's almost the same exact formula. So we're adding the velocity, and we're taking that velocity and we're adding it to position. And acceleration is 0 by default. So what I can do as a test is I can set the acceleration.y equal to 100. So it would accelerate 100 meters per second every second. So per second per second. So it's going to start off slow. Oops, I'm resetting the velocity every frame too. So equals 0. Get rid of this for now. Let me just show you what the acceleration looks like when you're adding velocity to it. So it's starting slow, and then it gradually gets faster and faster. If I make the acceleration negative, for instance, you're going to see it start slowly going up and then gradually get faster and faster. And eventually, it has infinite acceleration. It's kind of like a spaceship, right, in the vacuum of space. It doesn't decelerate over time. So now what I want to do is I want to change it so that instead of velocity I'm just changing acceleration here when I'm pressing up. And I'm not going to reset velocity. I'm going to reset acceleration instead. So I'm pressing up, and accelerations, you can see how it's a steady, and then I hold down up and he goes faster and faster. And we can make this more dramatic by increasing the rate of acceleration, by increasing that value. And again, this is just a change. If I just tap it, it moves pretty consistently. If I press and hold it, he gets faster and goes off the screen, right? It looks kind of like velocity, but it's not. It's not an instantaneous movement. It takes time for him to ramp up, just like a car, right? All right. The next step is I want to add behavior so when I press up, it causes the player to move in the direction they're facing. Watch what happens right now, facing right or down, I press up, and that's where I go. I want to be moving in the direction that I'm looking, right? So I am currently looking this way, right? My acceleration is telling me to move this way. This is negative 300 units per second per second. So what is this component? What are the x and y components of this? A better way to draw it, if my angle of rotation, if facing up is 0, and facing right is 90, and my rotation right here is what, like probably 120 or so, right? So I know that this angle here, I can take this is what, 30-degree angle? What are my x and y components here? What formulas can I use to calculate the x and y component, given I have an angle and I have this vector, this one right here, our hypotenuse of the triangle? You guys remember? Yeah, SOHCAHTOA, you can use sine and cosine to calculate both of these. So I can use sine here to calculate the x component, and I can use cosine to calculate the y component. And so what I'm going to do is I'm going to take my acceleration here, and I'm instead going to, instead of assigning the y directly, because this isn't correct, if I just set y directly, it's always going to move up. Instead, what I'm going to do is I'm going to have a speed. I'm going to set the speed to be 300. And my acceleration is going to be broken down. My x component is going to be equal to the sine of my angle times the speed. And my y component is going to be the cosine of the angle. Now remember though, in order for me to convert from sine, in order for me to call this function takes radians as an angle. It doesn't take degrees. So we need to convert from degrees to radians, right? And the way that you typically figure out conversions for things, if you guys, I learned this in chemistry class, but this is actually a really nice way to do the calculation. You have, I know I want to be, what I want to do is I want to find x radians, and there are 2 pi radians for every circle. And the equivalent is I have my current angle, which let's say in this case is 120, and I know that there's 360 degrees in every circle. So what you do is you cross multiply to get the result. You get 360, x times 360 is equal to 120 over 2 pi. And you divide both sides by 360, and you get x equals 120 over 360. Oh, no, it's not multiply. You want to divide both sides by 360. Did I say cross multiply? No, this is cross multiplying here. Like to get this formula, you guys ever do the cross multiplication? Yeah. X times 360, and then 120 times 2 pi. Yeah, you're right. Yeah. I was jumping ahead. You're totally right. This is 2 pi, and then I divide by 360 each sides. 120 times 2 pi, and then you get 360. And the reason why this kind of works is you put x in the thing that you don't know. So the units of conversion I don't know is how many radians I have. And in order for me to solve for that is by cross multiplying here, and I get x, and then divide both sides by that. So it's basically the angle divided by 360 times 2 pi. Okay. So divided by 360 times 2 times 3.1415. And we're going to take that and pass that in as the radians to the argument. And this will let us get an acceleration component. And I'm actually going to clear acceleration x and y at the beginning as well. Like so. And now I'm moving in the direction that I want, right? I'm accelerating in the x and y direction, except for up, which for us, because up is negative, we're going to have to reverse the y component here. It's going to be negative cosine, because up is, in SFML, up is negative. But now I'm accelerating, and I'm moving. You can see how a changing speed takes some time, just like a real asteroids game. And that's what acceleration does. Okay. All right. So let me give you guys this for